Hey, everybody, welcome back to your Dawn of Autonomy podcast. I'm Dawn Zolai, your host and the CEO of P3 Tech Consulting, as well as the publisher at Autonomy Global. We are in a month that we've dedicated to the theme of energy ops. And I cannot tell you how excited I am to speak with the two gentlemen we have on the show today. Laurent Zimmerli, he is with Voliro, and we've got Courtland Penk with Osprey Integrity. You may have seen Courtland a couple weeks ago. He's like a frequent flyer at this point on the show this month because we're talking about energy ops. And by the way, you're seeing the Suncor logo because they have sponsored this entire month dedicated to the theme, and we appreciate them. So welcome, guys, to the show.
Thanks so much, Don. Nice to see you.
Thank you, Don. Great to be on the show.
Well, great to have you. And what I want to do before we get into, what you are both doing together and what Voliro is all about is let's talk a little bit about yourselves first. So, Laurent, let's start with you. Can you tell us a little bit about your personal background?
Absolutely. Very happy to be on the show. Thanks again for having us. So I joined Voliro 2 years ago as basically the VP of customer experience back then, meaning I was responsible for marketing, customer success. In the meantime, I also included sales into the mix. So we built a growth organization. So I'm overlooking sales, marketing, as well as customer success. So that's been 2 years now. Prior to that, I've been already in the drone industry for 3 years prior to that. And in my previous life, I was actually in cybersecurity. So I had quite a change of industry between those two. But all my professional life, I was basically a mix of technical and customer-facing roles. I have an engineering background, but I moved into customer-facing roles like marketing and customer success early on. And that's basically where my expertise is and where I provide the value to Voliro today.
Awesome. Well, you say that, it's really switched from cybersecurity to drones, but honestly, drones are flying computers, as we know. So cybersecurity is a super hot topic, but we're gonna get into, your drone and everything you're doing with Voliro here momentarily. Courtland, tell us about yourself.
Yeah, thanks very much. Courtland Penk, founder and CEO of Osprey Integrity Company. It's a drone service provider that's based here in Canada and operates over North America. So back in a prior life, I made my living as a commercial pilot. Did everything from flight instruction, air ambulance, fire detection, and finally corporate. Ended up taking a change of scenery myself in the career after a layoff from corporate flying, and I found myself in industrial inspection. So I started to do things like ultrasound, eddy current, mag particle dye pan, all these different non-destructive testing methods, and grew that into the visual quality assurance role through API 510 for pressure vessels and weld integrity and things like this. So it was about 7 years ago that I took those two paths, smashed them together to start Osprey Integrity Limited. And we've really focused on drone inspection work in the heavy industry.
Awesome. Well, we're going to get into non-destructive testing. I suspect not everybody out there knows what it is. In fact, I didn't even know what it was, to be honest with you, until I heard both of you speak last year at Commercial UAV together. And it was such an interesting talk. I actually wrote an article about it for Autonomy Global. So when we launched it on January 1st, it was one of our feature articles on our homepage. You can, by the way, everybody still find it on the site. So check out Autonomy Global and the article about these two companies. But before we get into NDT, non-destructive testing, and everything else that you're doing together, let's go ahead and frame up the conversation with a video that we have about Voliro. And Lauren, I'm going to ask you to kind of tell us what we're seeing in this video. So let's go ahead and roll tape.
Absolutely. So we have a very purpose-built drone, which was really built and designed to establish contact with objects. So we're actually moving two objects to actually establish pressure and contact to, for example, as you mentioned, do NDT measurements, so inspection work. The drone is connected to deliver data to whoever is collecting it. It's built to work in let's say unideal conditions, wind, heat, turbulence. It can tilt all the way up and down so that we can interact in any direction, can navigate in non-GPS and GPS environments. It can maintain very stable contact so that the data that we collect is reliable. It fully integrates into the inspection workflows that Courtland is probably going to talk a little more later. You mentioned the NDT and inspection workflows. So we're basically just providing another tool to these methods of collecting data for asset integrity.
Well, like I said before we got on the show, I saw this drone and I met Voliro for the very first time. I think it was about 3 years ago at the Energy Drone and Robotics Coalition Summit. I think it might have been your big kind of US, unveiling, Laurent. And I just remember thinking, this is like one of the coolest drones I've ever seen. So purpose built, so unique. I love what you're doing, and I can't wait to talk about it more. But let's kind of talk about the origin story, though, because you focused on a very specific niche. You purpose built this drone, you and your company. So tell me, what is the origin story of Voliro?
Absolutely, more than happy. And actually, so you said that you haven't heard about NDT until you heard us talking about it last year.
Yeah.
When all of this happened, I guess probably nobody in the team, the original research team, knew about NDT, because it really started as a research project back in 2016. And the research task around it was, how can we build a drone so that it can actually interact with surfaces and objects in a stable way? So very general, very generic, without thinking too much about the specific use case. However, obviously knowing and expecting that there's so many different use cases where you can use a drone that can actually work and perform a task with an object or a surface at height. So that was really the beginning in 2016 at the Federal Technical Institute here in Zurich, with its Autonomous Systems Lab group, which does a lot of robotic research. And very early already within that project, it was clear that this is gonna actually be something that can be and needs to be turned into a product. So in 2019, the group basically spun off and founded or incorporated the company in 2019. So the basic technology, or the design as we see it today, the basic design was born, but again, without having too much of a use case in mind. And so that basically brought us to a second phase where it was all about, okay, how can we basically use this technology to create value in the field for a client in real life? And that's when we went into the early adoption phase, where on the one hand, we were speaking to big corporates like Shell, Petronas, Holcim, mostly industrial companies, to see where they see fit for the technology. At the same time, we were also starting to have conversations with people like Courtland, who are using these tools for asset owners to basically do these inspections. And then we tried everything you can imagine: cleaning, spraying, grinding, drilling, everything you can imagine that somebody could do with a handheld device, but without having that person on the handheld, but instead having that instrument or tool on a drone. And during early adoption, then we basically narrow it down pretty quickly to these NDT use cases that we're going to talk a little more about today. So basically doing inspection, non-destructive inspection of materials by applying pressure with an instrument to a surface and basically reading data. So that was basically the main focus. And in 2022, so about 2.5 years ago, we launched the product. And part of the initial product was really that set of NDT sensors that are still in use today and that have been used in the field now for over 2 years.
Okay, so I'm going to right away deviate from the script, and I'm going to go over to Courtland, because at some point, Laurent, you opened the door to this. You said you were talking to people like Courtland. Courtland, obviously, you're an expert in industrial inspections. Can you explain to everybody what NDT, non-destructive testing, is all about? And in that explanation, explain why it's so important.
Yeah, I can do my best. I think Laurent definitely gave it a good start there, right? This is a non-invasive, a non-destructive. We're not going to destroy the material. So I would say that almost everybody with just doom swiping and getting their dopamine hit on tech these days has probably seen some type of metal being stretched to a point of failure, right? You have some kind of piece of metal, or you see something fatigued to a point that it cracks, something like this. So that would be more destructive testing, right? You're actually destroying the material to determine its breaking point. So these
Okay.
non-destructive testing technologies, and there are a lot of them, definitely a lot of methods to achieve this, but think of determining a fitness for service, like how suitable is that material to continue on doing its job for its intended purpose, but we don't have to destroy the material in the process. That's about as confined as I can kind of sum that up.
Okay. I mean, as you're talking, and I know we have some images we'll show later of maybe kind of tanks. I also think of use cases like maybe ships. Yeah, in other words, anything that has been in service for a while, that if for some reason it buckles or breaks or cracks, as you say, could be a big problem for people.
Yep.
I can imagine there's a lot of different use cases, not just on the commercial side, but on the military side as well.
It's almost everywhere. That's the thing. So when I first got into this field, I had somebody describe it as we're the ninjas of the industrial world. You're almost everywhere, but nobody knows you're there. Nobody knows really what you do. People hardly see you, but you're everywhere. So, use cases are so it's thickness material, say for pressure retention or vacuum kind of protection. It can be in weld joints. It can be in plastics and rubber and in composites. It's honestly everywhere, and it's completely industry agnostic. I mean, think bridges, think manufacturing, think petrochemical, think yeah, ships to your point, and aircraft, and it's honestly everywhere. The type that is used, it's always to generate a specific test, right? Depending on the construction design of the system or what's under inspection. But it is everywhere, and it's not just for what's in service. Sometimes non-destructive testing methods are used as part of commissioning. So we have things that come from manufacturer, they get tested and non-destructively, they get installed or welded together, everything like that. And honestly, it's everywhere. So yeah, very broad, lots of
Yeah,
opportunity.
that's amazing. And I'm going to go back to Laurent. I'm you're kind of lucky in a way because you guys built something really cool and it was a solution in search of a problem. I always talk about this, like people do that, and you were fortunate that your product, like Courtland just said, has just this innumerable amount of use cases. Not everybody is so lucky. But I want to ask you, Laurent, how what makes the drone that you created so unique? And first of all, we haven't even said its name. So tell everybody what it's called and why it's so unique.
All right, so the name is rather boring, I'd say, because we just simply call it Voliro T. The T though has a meaning. It comes from tricopter, because, and if you look at it, the drone, or if you think about a drone, usually what you have in mind is a quadcopter, right? Four propellers, like in a rectangular kind of arrangement, and that's basically what you picture usually. So coming back to your question, what's so unique about it? The uniqueness is the design, and the design is done or like was made for a particular purpose. And as I mentioned in the beginning, the purpose of the drone is really to interact with objects or surfaces, meaning applying pressure and force. And now if you think about these conventional drones, these quadcopters, or actually even if you think about a helicopter, when you see a helicopter or a conventional drone, it hovers stable in the air, can stand still, no problem, very stable. As soon as it starts moving, it basically starts to tilt. So to move forward, it tilts forward. To move left, it tilts left, etc. So that's basically how physically it makes the vehicle move. And in motion, it stays completely stable. It's a perfect way of moving forward, backwards, sideways. However, if we talk about applying pressure and force, we don't want to move. We basically want to kind of do a similar motion, but without moving the drone. Now, the problem is, as I said, tilting is usually required for those vehicles to apply this force. Now, but if you tilt and you don't move, you lose stability because your center of gravity is going to move into a place where it's not ideal, and at some point you're basically just going to fall over. So that's where now this tricopter design that we have, and this very particular design, comes into place, because what we've done is, first of all, we made the rotors tiltable. So the rotors, basically the two main rotors, like on the side of the arms, they can tilt independent of each other in any direction. So this way, they can actually move the vehicle without tilting or moving the vehicle as such, because the rotors are basically tilting in that direction. So that's number one. And then the third propeller that you see on the tail, that's basically used to stabilize while we're doing the interaction. And that's also used to move the drone upwards and downwards, like we saw in the video in the beginning, so that we can not just interact horizontally, but we can actually do it in any direction. So that's
360 degrees. Are we talking 360 degrees?
Absolutely, because we can move all the way up, all the way down, and sideways. So in the end, any possible angle can be covered.
And I want to put a little color in there, if I could, Don, just a little color on why that's so important to us and why it's such a front runner in the industry for its applications. We can't go out to any site and not come across something that is domed or on angular contacts, and there's everything from 10-degree slope to 70-degree slope and everything in between on some of these curved surfaces. So when we bring a solution, we have to, I guess, ideally be able to say, yeah, it doesn't matter the angle. We have a contact capability for that angle and for the design of your equipment. We can do more of your assets with this one design.
Well, that's crazy. And it's not just like a momentary application of force, to use your words, Laurent, but also, you know, from a stability standpoint, you can do this persistently. In other words, you can maintain contact around a dome or with those angles that Courtland just mentioned persistently. And that, I assume, for measurements, that is what makes your drone, the Voliro T, so incredibly unique and different. So in terms of problem solving, because we talked about this amazing solution that the team, you know, crafted to have a drone that can remain in contact with an object. The problem you're solving there is exactly what? Just to kind of put a pin in it.
Absolutely. So if we think back of what Courtland mentioned earlier about NDT in general, it's mostly about infrastructure, productive infrastructure, critical infrastructure that has a purpose and that lives, let's put it that way maybe, and needs to be maintained to basically live on and do whatever it is used for. Right. And to do this maintenance and to make sure that the infrastructure is fit for purpose, we need to collect data. And that data is being collected in very different ways. And that's part of all the whole inspection world that Courtland was teasing or talking about. I mean, the easiest kind of data that you can imagine, obviously, is visual data. So you can look at things, you can have a camera or use your eyes, obviously. You can have a thermal camera maybe. And then, so that's the first step. But then when it comes to sensing, touching, sensing, we can collect data like thickness of material, thickness of paint, that basically, again, gives you data on the state of the infrastructure, so that you understand the health, so that you understand if and what kind of maintenance might be required to make sure that the infrastructure stays, the integrity of the infrastructure is basically kept in place, in a good shape. And when it comes to collecting that data, and now coming to your to your question about the problem statement, there is certain locations where it's hard to collect data, where there is risk involved, and where it's very time consuming or expensive in terms of time or cost to collect that data. And that's exactly where our solution basically now can provide value. because in many of these locations, the drone can do it faster, more efficient, and can reduce unnecessary risk that needs to be managed when doing it manually and can be eliminated when using a drone.
Well, and not only that, but I also imagine part of that return on investment is there's no downtime potentially. In other words,
Absolutely.
you don't have to say it's some kind of a wind turbine. I think we're going to get into that use case, or something that is in an operational status. You don't necessarily have to shut it down to be able to do this. It's like bridge is a great example, Courtland. I know because I've done some research on this, that when there has to be a drone, when there has to be an inspection of a bridge, they have to shut it down, the traffic, for sometimes hours, and that not only creates all kinds of problems as a practical matter for real people on the ground, but also just kind of the money, if that's a toll bridge, that people lose in that time frame. So the return on investment for something like this is super significant. And Laurent, I want to go from general and then down to specific to that use case for the turbine in a second. So let's stick with the generalities. We kind of alluded to some of these use cases on the industrial side, but I want to hit some of these. How does Voliro's flying robotic platform help industrial inspections across multiple sectors? In other words, what are the sectors that have already benefited from using this drone?
No, absolutely. And I think the downtime is exactly the best segue to move over to this part, because downtime, of course, it has huge impact. And that's basically also coming back to talking about what I call productive infrastructure. So if you look at, and I mean, going back to the theme of the month, energy, of course, if you have a plant or a refinery, every minute, probably even not even hour, but minute that you have to stop production, there is a significant loss in money and productivity. So whatever can eliminate it there in terms of downtime is benefiting the asset owner and operator. And to name a few examples, and that's going back to the talk when you first heard us talk about it, is for example also mining. So we were talking about a search bin, critical piece of infrastructure in mining, where the ore is being processed. And every hour that this piece of equipment stands still costs a tremendous amount of money. And Courtland basically used our technology to reduce a repair scope that was planned so significantly that it literally ended up the client saving more than $1 million Canadian for that individual inspection. And this is the kind of dimensions we can, of course, not every inspection is that kind of a dimension, but it can easily go, or it can go up to there. So mining is one example. Oil and gas, of course, turnarounds. If we have these turnaround periods where everything has to stand still, if you manage to do some of the scope of work beforehand while the infrastructure is in service, you can reduce the scope of work, or you can do more work during these turnaround times, basically where you have planned downtime. So you can basically extend there, do more, gain efficiency, and maybe even extend maintenance cycles of specific assets. And then you were mentioning wind turbines. Of course, if a wind turbine doesn't spin, it doesn't produce energy. And if you want to inspect it, it cannot spin, so you need to stop it. So the longer you stop it, the less it can produce. Same here. If we're looking at the numbers, we're talking for the particular kind of inspections that we do with our drone, we can do 5 to 10, sometimes under ideal conditions, even more than 10 turbines per day. If you look at conventional methods, we're rather talking about 2, maybe 4 per day. So that's a significant difference there as well. Transmission lines, same here. Transmission lines, if the grid has to be taken offline, it's a huge effort. If you don't have to climb the towers but send a drone, the grid can be online, and we can do many more towers in a day as opposed to when we have to climb up there.
Amazing. And now you mentioned, some of these applications involve thickness measurements. We're going to nerd out a little bit here, so I'm going to go back to Courtland, because I know you're working with the Voliro T and all of these different sensors. But can you walk us through? Again, not too extensively. I'm talking like a quick around the world, if you will, the different thickness measurement methods that help ensure asset integrity across some of these environments that Laurent just mentioned.
Yeah, absolutely. I'd like to put a quick bow on what Laurent was just saying as well with the value, right? And where does this fit in? And the answer is sometimes it's just incremental, but we've reduced a massive exposure risk. And then sometimes it's up to and just almost unquantifiable. And it's typically a hybrid of both direct savings and opportunity cost that's left on the table from everything being able to stay in operation or limit that downtime, becoming more I guess up to speed. You have a better context of what's going on if you decide to increase your scope because now you have time and budget. So you can do more, get a better idea. And that starts to spin into what we were talking about with Ted a little bit a couple weeks ago, right? In that preventive maintenance side. So we start to be able to get ahead of things a little bit and prevent the big, they call it break-in work, right? So break-in is a surprise. That means you're breaking into the maintenance schedule to react to something. And the less we have to react to something, the more everything is dependable with costing and cash flow and your maintenance scheduling prioritization. So it's almost this big revolving machine that the more we can do, the better grasp we have on the up-to-date health of a facility, increased coverage, and pardon me, and do a little bit more frequently, depending on having the available budget, time, resource, things like this. We make a smoother machine, and it's almost all tied into the same conversation.
No, it makes an abundant amount of sense. And to do this, you have, you mentioned early on, I mean, I didn't want to interrupt you because it was like the beginning of the show, but you mentioned like eddy currents and magnetic thickness, to kind of give us the rundown of some of these quickly, because I really want to get into the turbine use case and specifically, and we are, as always, running out of time because this is so interesting. So go ahead and tell us a little bit about these thickness measurements, and then we'll get into the wind turbine use case specifically.
Yeah, time flies when you're having fun, right?
Yes.
At the end of the day, NDT, it can be broken down into different methods, like I alluded to. So ultrasound, eddy current, magnetic particle, dye penetrant, radiography, acoustics. There's different methods here, right? Could even throw microwave into the mix there. So as far as thickness testing, it's mostly done with ultrasonics. So this is essentially it's called a piezoelectric crystal. That means that you can make electricity make a mechanical wave out of electricity and then convert it back. That's what that term means. It goes back and forth. So really, it's that technology that is using electricity to create a sound wave in a material based on some known values of speed, velocities of speed. We're able to then determine basically time equals distance and generate a thickness. That's how that gets summed up pretty quickly. Using things like electromagnetic acoustic, which is implemented on the Voliro, it provides us some nice flexibility for surface degradation or contamination. And it uses essentially a non-contact method. It uses eddy current technologies to induce a mechanical waveform. And then we're back to just the same thing I just explained. We've got a known velocity. We've got now a time measurement to turn that into a distance. That's being used across everything. And just to really quickly tidy this up, really who's using it at the end of the day are the reliability and the mechanical engineers who take this data to run math, essentially, based on these known values to determine the structural suitability to continue to operate at known temperatures, pressures, volumes, all these things. So it's the engineers that end up taking this, running it through, determining corrosion rates, create an asset integrity program, adjust it as necessary based on up-to-date information. And the more you get to do that, the better lens you have on the facility health, and the less you have those break-ins.
Well, as they say, an ounce of prevention is worth a pound of cure, to be sure. And in these types of operations, I imagine that is probably exponentially greater than just a pound of a cure. But so I imagine there's all different kinds of sensors for all of those different measurements you just said, Courtland. So I'm going to go back to Laurent and ask him, um, those sensors, plug and play with the Voliro T? Are you creating your own sensors, or how does that exactly work?
So the sensors as such, so the piece, basically the instrument that does the measurement is not something we produce ourselves, because
Gotcha.
obviously there's experts creating this, let's say off the shelf,
Yes.
and we're integrating this. So but the integration work is crucial because of what I also mentioned earlier in the conversation, to integrate this into existing workflows, because the whole inspection business is nothing new. They're very established workflows and processes and methodologies. So you basically, even if you create a high tech and very new kind of technology that you want to bring into this industry, you have to make sure that it fits into the existing processes. So we're taking industry standard technology and then integrate it into the drone as if it was a conventional instrument, meaning it's while you're flying, you basically, and taking the measurement, the person, the operator on the ground, and even a second person, the inspector on the ground, sees on their tablet exactly what that drone is measuring or what the sensor is measuring. So that means that for them, it's actually not a difference. It's just a different kind of getting to where the data is collected, but the way the data is presented is exactly the same. So and that's what makes the integration work so important. So we're using off-the-shelf UT technology, EMAT, even Penk, everything, not everything, but some of these instruments Courtland mentioned, and we're integrating them in a way that they can be used on a drone. So the data is collected by the drone, but basically inspected by the person on the ground as it was a handheld instrument. And now
Okay.
you were basically repeatedly asking or mentioning the wind turbine. I guess wind turbine is a little bit of an outlier for us, because what we do is we do one very particular test there. And even though if it's a non-destructive test in terms of we're not destructing anything, it's probably not something that you would consider a traditional NDT method. So because what we're doing here is we're testing the continuity of the lightning protection system. Because wind turbines, obviously, by their nature, are very much exposed to lightning strikes. They're tall structures in an open field, or even offshore, even more, onshore usually as well. So if there's a thunderstorm, they're very much exposed to lightning strikes. So all of these turbines,
literally, they're like lightning rods. It's like,
absolutely,
come please strike me.
magnets.
Yes.
Exactly, that's what they are. So that's what you do, is you basically build in lightning protection systems, just basically the same way you do with buildings. So they have little metal receptors along the blades that can ground a lightning when it strikes the turbine. And if that grounding works, no damage done, because it's just going to be grounded to the earth, nothing serious happening. However, if the grounding doesn't work, there can be severe damage, and there's lots of flammable material in the turbine as well. So that's where it gets dangerous, and that's where there can be harm to the infrastructure. But also, if it collapses, obviously, much more harm to the environment, and worst case, also people around it. So that's where that use case comes in. Now, to test the continuity, and now I have to be a bit technical to explain that. I try to keep it as high level as possible. But basically, to test that, you need to create a continuous loop where you can put a current through and see how much the resistance is. Or first of all, see, is there continuity? And if so, how much resistance is there? And if the continuity is there, and if the resistance is low enough, you know it's easy for a lightning to get grounded, and that's what you want. However, if there's no continuity, if there's high resistance, you know that there is a damage somewhere on the system. And that's basically what we want to find out. Now, that's not so easy because of the structure of a turbine. It's tall, you need to, and the receptors are on those blades, as I explained. So for a conventional testing method, what you do is you climb up the tower, and then you hang on a rope and you climb down the blade. And then you have a handheld device you push it against these receptors. You have a long cable from that handheld device back up to the hub of the turbine to create that loop that I was explaining.
And
then
you're
you measure
literally
the
some dude out there, like, basically beaming electricity
Yes,
onto a blade. Oh,
that's
that sounds,
exactly what is
and
happening.
over water potentially. Super
Yes.
safe. Like, sign me right up. Wow.
That's a brave people. I have a biggest respect for those people who are doing this. But there is not enough of those people, actually. There's much more work for those people than they can do. And there is still a lot of tasks that a robot or a drone probably will not be able to do in a while, like repair work, etc. But if we look at the testing, the simple, let's call it simple testing of the lightning protection system, that's something that we can do. Because what we can do is we can use the capability of the drone to push a needle, basically a metal needle, against these receptors. And then we have a very thin cable from the drone going down to the ground that is basically connected to a resistance ohm meter, and that is grounded. And that basically creates that loop. That means we can do an inspection of a turbine, depending on the model, of course, depending on the conditions, but usually I'd say between 20 and 40 minutes for a complete turbine. If you have to climb it, it's going to be easily a few hours for a turbine to be completely inspected.
Wow, that is, and I know cost savings. There's a lot of ROI here. I don't know, we'll be able to get into all of them, but by the way, everybody, in about a week or so, we'll have an article on Autonomy Global about this show. I'll elaborate on some of the things we weren't able to get to, just because there's so much to cover in terms of what Voliro is bringing to the fight for the energy sector and this non-destructive testing of so many different things. But I do want to talk about the UT, or ultrasonic testing, specifically of some industrial structures, Laurent. So this is a little different than what we were just talking about. It was a very niche use case in terms of the wind turbines and those lightning sensors. Tell us a little bit about the UT solution using your drone and the industrial structures that benefit from that.
Yeah, so structures is basically anything, again, that you can see on a plant, and that's the perfect picture to illustrate that. So we're talking stacks, chimneys, storage tanks that you can see in the background, pipes, overhead piping, boilers, silos, anything usually made of steel, let's put it that way, to put it simple. So what you can see in the foreground here is a stack, an in-service stack that is made of metal. And you can see that ultrasonic testing instrument that you were mentioning on the drone that is being pushed against that. And then it's using the technology that Courtland was explaining. So it basically creates ultrasound waves that are traveling through the material and back, and then enabling us to measure the thickness of this particular location of the chimney. And this can then be compared to the nominal thickness. So say we know that this chimney is supposed to be 1 inch thick. I'm just making up numbers. Now, if we're measuring maybe 0.75 inches across the length of the chimney, that might still be normal because it's maybe 50 years old. But if we come across a location where it's significantly lower, we know that there's an indication of corrosion, meaning that the integrity of the material at this particular location is not how it's supposed to be.
All right, very, very cool. Love that note, besides the tricopter design, the nose that puts all these different sensors into play, just so super unique. I want to go back to Courtland. I mean, you've been working with Voliro for a while now across many different use cases. Just kind of in general, what is the Voliro T bringing to the fight in terms of the services that you're providing to the energy sector, across a whole bunch of different markets?
Yeah, so great question. We, like I alluded to earlier, with the full 360-degree touch capability, we're looking to bring tools to our toolbox that we can tick as many boxes as possible in one visit. Right? That's the nature of trying to be a cost-efficient and operationally sound service provider. Of course, those timely insights go directly into the business unit decision making and up to speed aspect for the asset owner. So time literally is money, trying to get ahead of something and be preventive, right? As best we can. So it's what Voliro is doing as part of our toolkit is allowing us to do just that. We can show up with a suite of tools and be able to take on almost anything that we're asked to achieve with respect to drone inspection capabilities today, right? So I had something to add on as well. Right, the stack. I'm just gonna a couple things there. So one thing worth mentioning that hasn't been yet is the high temperature capability. So we showed a stack here, and a lot of questions that come up are, well, can we do that while it's in service? We kind of alluded to that earlier, but that sensor, Laurent, correct me if I'm wrong, but I believe it's 550 F for the high temp.
500.
500,
Yes.
525 F. Gotcha. Yeah. It's so 500 F for live assets. And that's a big determining factor there. The other thing that I wanted to add, I know I'm kind of jumping around here, but lots going on upstairs right now. The other thing that kind of comes in, Laurent talked about, we note having, say, a 1/4 inch of loss. I'm going to spin that back to where I talked about yeah, just basically how that's used. If we have the time frame between the last inspection and the most up-to-date inspection, the inspectors and the engineers get to start to create the short-term and long-term corrosion rates, which actually help dictate those maintenance intervals that Laurent was talking to. Oh, well, actually, our corrosion stopped. Great. This is awesome news. We can inspect further along down the calendar. Oh, it increased in rate. We should probably get to this again soon so it doesn't fall over. Last but not least, I think super, super cool development that's really fresh this year is pull steady current. Also being integrated onto the Voliro through designed by Penk. And what this system allows us to do is look for wall loss, volume loss of material through insulating materials. Within the means of the technical capability of the sensor, everything's got a limit. So in this case, it's roughly 4 inches maximum thickness of insulation and roughly just shy or just over 3/4 of an inch in material thickness. So everything that thick or less and 4 inches or less of insulation, we can have a look through using pulse echo. So it shoots out energy and then we listen for the decay of that signal. And depending on how that signal decays, gives us an indication of the remaining wall volume or steel volume behind that insulation. So if you think about maintenance costs and the ability to get up there and screen and have a look just to start wrapping your head around, do we have problems here? Or is it consistent? Yeah, we have a way to do that without having to put somebody up there, remove insulation, then do UT thickness testing, then put your insulation back on, and then do that all over again. Right. So it's
and I guess that's exactly coming back to the beginning of the podcast. That's exactly where we want to add value by providing multiple different tools for different tasks to cover as many aspects of the workflow as we can. So we started with these NDT sensors that I mentioned for the material thickness and paint thickness. And now we're adding on. So the Penk is just basically yet another tool to broaden the scope of the inspection tools that you can use with the.
That's amazing. So that's kind of one of the newer things. We only have like a minute left, Laurent and Courtland both. I want to give you the opportunity to very briefly tell us, number one, what's next for you? And number two, how people can reach you. So let's go to Courtland first, real quick, and then we're going to end with Laurent and Voliro.
Really quick, really concise here. I'll be down at AUVSI, be on a panel in the afternoon of the 20th, talking basically to the energy sector and drone asset owner, that whole sphere. And I think what I'm really excited about is energy drones and robotics in the Woodlands in the middle of June. We're going to have a really exciting showcase that does feature the Voliro work and some really cool Industry 4 or 6.0, depending on which one you like these days. So that's where we'll be next. You can reach us. I'm at Courtland at ospreyintegrity.com or on LinkedIn. Fairly active there. And yeah, that's where you can get me. That's what we're up to next.
Amazing. Thank you. And last but certainly not least, Laurent, tell us a little bit what's next and how can people find out more about Voliro and the Voliro T?
So I guess the most exciting thing that we're actively working on, and that we gave a little preview earlier this year actually, is that we slowly want to move over from what we call sensing to acting. Because what we were talking about today is using this force and pressure to measure without destroying. What we want to eventually get to is that we can actually act. So doing physical work. So you might have seen a video on LinkedIn where we actually created a gripper payload where we can pick up an object, in that case, a light bulb, and we screwed it into the socket. Of course, that's kind of a fun application, but the idea is to demonstrate that just applying pressure is not the end, it's just the beginning. So we really want to make this move slowly but steadily from sensing to acting. That's the ambition, that's what's up next. And in terms of how and where you can reach us, I guess it's just exactly the same as for Courtland. You can reach us on LinkedIn, the website, and yes, we're going to be at Energy Drones and Robotics in Houston as well. More than happy to see you all there.
Amazing. Well, thank you. Thank you, everybody. We are out here.